Is my voice audible? Okay. So today we are going to start our lecture. So in the previous lecture we saw the different measurement devices which will measure the dissolved oxygen and also the different salts or the minerals which are already dissolved into the water. Now these minerals causes the corrosion problem and also the oxygen, that is dissolved oxygen which is present inside the feed water, it is also causes the corrosion problem. Okay, so that's why we have to first of all measure those oxygen or the dissolved salt into the water, the feed water. Then we can control or we can implement the different control systems to control the levels of the dissolved oxygen and the levels of the dissolved salt. Similarly, the measurement of the pH value of the water is also important because this pH value is going to affect the different materials which is came in contact with the feed water, right? So generally, the basic information regarding the pH scale that you already know, I think, because in chemistry classes you already know what is meant by pH and what if the value of pH is high, then what is the base of that particular solution. So similarly, if we saw the pH scale, we are consider the 7, the number 7. If this pH value is 7, in that case, we are considering that solution is a neutral solution, right? Means it doesn't affect the other material or the other fluid if that pH value of that particular solution is the 7. So this is considered as a neutral solution. Now, if the pH value is greater than 7, in that case, that particular solution represents the alkaline solution. Okay. So there are three type of solutions we saw, that is the acidic solution, alkaline solution, and the neutral solution. So if pH value is 7, in that case, we are considering that solution as a neutral solution. Then the best example of neutral solution is the pure water. Okay, I am saying that it is the pure water, not it doesn't contain any dissolved salt or any dissolved gas inside it. So pure water, which having the chemical formula H2O, that water contain or the pH value of that water is the 7, and we are considering that solution or that water is the neutral solution because it doesn't react with other materials in any cases in normal conditions. So we are considering the pH value of pure water as a 7. Okay. Now if the pH value, if it goes on increasing the pH value, then that particular solution is start to become the alkaline. Okay. So from 7 to 14, the total scale or the total numbers having on the pH scale is from 0 to 14. If the value of that solution or the pH value of that solution is in between 7 to 14, in that case, we are considering that solution as a alkaline. Okay. If it is greater than 7 and less than up to the 14. So as pH value is going to increase is from 7 to 14, that solution start to become increasingly becoming the alkaline. Okay, and if the pH value of that solution is dropped below 7 up to the 0, and if it is approaching the 0, in that case the solution becomes the acidic solution. Okay, so that's how we can classify the type of solution. And importance to calculate the pH value is that because this alkaline nature or the acidic nature of the water, it is going to be affect on different construction materials of the different devices which are available in thermal power plant. So if you saw in boiler, there are boiler tubes are there, boiler shell will be there. Then similarly, the steam which is carrying the pipes which are carrying the steam, then the feed water, also the different tubes which are present inside the condenser, etc. So there is particular pH value. If the particular feed water is more alkaline or more acidic, it is going to be affect the construction material, and indirectly it will going to affect the life of the power plant. So the pH value, as we know, it is a simple number between 0 to 14 or on the scale of pH, on the pH scale, which will detect the degree of acidity or degree of alkalinity of the particular solution. So the scale formation or the corrosion tendencies of that particular solution or the feed water is largely depend on the pH value. So if the pH value is low, means if that solution or the feed water is more acidic, in that case it will favor the corrosion problem. Okay, means corrosion reaction will be increases. The speed or the rate of corrosion reaction has been increases if that particular feed water is more acidic. If that feed water is more alkaline, means its pH value is greater than 7 and it will approaches towards the 14 number, then in that case, it will precipitate the calcium carbonates or the different dissolved salts. Again, this precipitated calcium carbonate is going to create the scaling problem, as we know. And because of this scaling problem, if that calcium carbonate will precipitate on the inner surface of the boiler tube, or the inner surface of the condenser tube, in that case it will reduce as the heat transfer, and that will going to affect the efficiency, or we can say the performance of that particular instruments or the device. Okay, so that's why we have to control this pH value. First of all, before controlling, we must know what is the pH value of that particular feed water or given feed water sample. Okay, so to measure that one, we are using the pH meter and we are using the different methods. One method we are going to study in this particular point. Okay, so to overcome this scaling problem or the corrosion problem of the water, its pH value must be controlled by the chemical treatments. There are different chemical treatments. The treatments are available to control the pH value. The pH value of feed water is controlled to up to the minimum value of 10.5. Generally, if you consider we are going the ideal condition of that feed water is the pH value must be 7. Okay, that is the neutral solution. But to reduce the corrosion problem, what we do, we just increases that pH value of the water up to the 10.5. So we are maintaining the pH value of that water up to 10.5. So the corrosion will be less. Okay, so in that case, corrosion will be less, but scaling problem will increases. Sometimes the precipitation of calcium carbonate will increases. So that's why we are not exceeding that value beyond 10.5 or the beyond 11, 12 pH. Okay, so this particular value is high enough to prevent corrosion. At the same time, it will allow the precipitation of various scale forming salts. So the precipitation will take place. We have to remove that dissolved salt. It will help to remove those dissolved salts. Now, first of all, before controlling the pH value, we must know the feed water. What is the pH value of that feed water? And for that, we require some measurement instruments or the measurement devices or the measurement techniques. Okay, so that we are going to see here. So measurement of the pH value. So this is one of the method which we use to measure the pH value of feed water. That is electrometric method of pH measurement. Okay, so this circuit you will see here, it will contain the pH measurement or it will contain the circuit which will measure the pH value of the circuit. So you will see there is a reference electrode is there, test solution is there, which is inside this particular beaker. Then this one is the glass electrode. It is connected to this thermoionic wall, and the reference electrode is connected to the one potentiometer. Okay, this one is the potentiometer. This particular meter will indicate the pH value directly, and it is connected to the battery because we require some voltage. Okay, now here what will happen? We take the test solution inside this beaker, and inside the beaker we put the glass electrode and also the reference or the test solution electrode. Okay, now what will happen? Now this reference electrode also you can see there is a tube. Okay, and inside which there is a one electrode. Okay, now it will in this particular tube we fill this tube with the reference solution. For the reference, we can take as one solution which we would uh, pH value we already know. Okay, so we put that particular solution inside this tube, and we are considering this one as a reference one. Now what we do, we put the sample value inside this beaker, and we start or connect the batteries. In that case, what will happen now? The pH value, how it is considered, or how to measure the pH value. If you know something regarding that different ions which will present inside the acid and inside the alkaline solution. So if you consider there is an acidic solution, it will contain more hydrogen ions. Okay, H plus ions we are considering. So if that particular solution will contain more H plus ions, it will consider as a acidic solution. Okay, this one is considered as a acidic solution. Okay, and if that particular sample or the solution will contain OH minus ion, okay, then it is considered, or we call it as a alkaline solution. Alkaline alkaline solution. Okay, so depends upon this particular pH values, depends upon how much hydrogen H plus ions are there and OH minus ions are present inside that particular water. Okay, these are the three ions which must be present there. Now, what we are going to do, we start the or we connect the batteries. Then in that case, what will happen? This glass electrode, it is having the negative, it has been connected to the positive one, and this reference will be connected to the negative one. So in that case, what will happen? The H plus ions will be collected towards this, or it will transfer from glass electrode or the solution to the glass electrode, and in that case, this deflection or the difference between this particular charge, because this H plus ion will contain positive charge and OH minus will contain negative charge. So because of the imbalance, you will see there is some value will be displayed by that particular meter, or that particular measurement meter. Okay, so like that we will measure the pH value. Okay, this one is the potentiometer, one potentiometer circuit and another circuit. There are two different circuits we are using here. Okay, so by using this particular instruments, we can measure the pH value. Now this meter will indicate some reading. That reading we have to take. Okay, and by using this particular reading or this particular formula, you can calculate the EMF. Okay, so the measurement of pH factor is carried out by means of the glass electrode that we saw and the reference electrode, which are deeper into the solution, and the EMF is measured by the pH meter. Okay, that pH meter will measure the EMF, which is the current which is passing through that particular solution. When the glass membrane forms the boundary between the two solutions of different pH values, a voltage is developed across the membrane thickness, which obey this particular law. Okay, so by using this law, we can calculate the pH value or the EMF generated, and that EMF is directly proportional to the pH value. Okay, so the pH value of known solution, that is given by pHx. Okay, sorry, that is given by pHx. That is the reference. Uh, uh, that is the reference solution that we put inside this particular test solution, or inside this particular reference electrode. Okay, that is the pH. Yes, that is the value of known solution pH value. Then pHx is the pH value of solution that we must be determined, or we must be find out. Okay, so this is the requirement. Then R and F are the chemical and physical constants. This R and F is the physical and chemical constant, and this T is indicates the absolute temperature, whose scale is Kelvin. Okay, now the voltage developed in temperature, this voltage which is developed, this EMF, it depends upon the temperature. Okay, so we must maintain the temperature of that particular solution. Okay, because it is depends upon temperature. As temperature varies, the EMF generated inside the circuit will varies, and it will directly going to affect the pH value, because the EMF generated inside the solution, it is the indicated the pH value. Okay, so that's why we have to maintain the temperature. When a glass surface is deep inside the solution which is containing the hydrogen ions, it also develops electropotential potential which is proportional to the hydrogen ion concentration inside the solution. Okay, so therefore, the glass electrode can be used for measuring hydrogen ion concentration or the pH value of that particular solution. Means whenever we dip this particular glass electrode, because of the hydrogen ions which are present inside this solution, there will be a potential, the voltage will be generated or the EMF in between glass electrode and the reference electrode will generate it. Okay, and that EMF will be, we are going to neutralize by using this potentiometer. Okay, and because of that, what will happen? It will neutralize in this particular circuit, but it will indicated that variation of this particular EMF will be measured by using this particular meter. Okay, and that EMF generated or the EMF shown, it is directly proportional to the pH value. Okay, it will indicate indirectly indicate the pH value. It will indicate the numbers of hydrogen ions present inside the particular solution, and it will indirectly uh, shows us the pH value of that particular sample. Okay, so that's how we will measure the pH value. This is one of the type of method which is used to measure the pH value of feed water. Similarly, there are more methods are available. You can directly measure the pH value by using pH meters or any other method. Okay, this is one of the methods which are used to measure the pH of the sample. Now, this that's how we will measure the pH. Now, after measurement of the pH, we can decide whether we have to carry out some procedures or we have to carry out some chemical treatment on that particular water or not. Okay, if the pH value is far below than 7, if that particular feed water is showing the acidic solution in properties, in that case we have to increase its pH value. If the pH value is very high, means around 12 or 14, in that case we have to reduce the pH value. So that's how we will decide after measurement that if you want to carry out some chemical treatment to reduce or increase the pH value. Okay, because it will indirectly going to affect the life of that particular power plant, life of the different devices. Because as we saw, the acidic nature of the solution, it will increase the rate of corrosion. Okay, and similarly, the basic nature, alkaline nature of that particular solution, it will going to only causes the precipitation of the scale, and that will again going to give us problem inside the boiler tube, or it will reduce the life of the boiler tube and also the condenser tube. So that's how we can calculate the pH of that particular feed water, and it is very important to measure the pH. Okay, if if that particular pH is beyond the limits, in that case we have to carry out some chemical treatment, and then we can use that particular water for the in the thermal power plant. Okay, so this is the one of the type of pH measurement. So these three measurements we have to carry out, or we have to carry out these particular procedures on the feed water. That first we saw, that is measurement of the water purity. In that case, we first saw the measurement of dissolved salt, which that particular feed water contains the dissolved salt, how much dissolved salt. Then the dissolved oxygen, that feed water contain how much dissolved oxygen. And third one is the measurement of the pH value of that feed water. Okay, so by measuring these particular properties or the values of water, we can carry out the different procedures or the chemical treatment. So we can took those or the reduce those values in between the limits or the required limits. Okay. Now, next measurement technique that we have to find out, which is related to the flue gases. Okay, as we know, the thermal power plant will contain the boiler, and in the boiler there is the one part of the boiler is furnace, where the combustion of the fuel will take place. So, particularly in case of coal-based power plant or the natural gas-based power plant or the any diesel or petrol-based power plant. So, in that case, what we use, generally uses the different petrochemical products or the coal as a fuel, and by using that we burn that particular fuel inside the furnace, and that will create the heat because of the chemical reaction combustion. It will create the heat. That heat has been transferred to the water, and that's how we will generate the steam. So after generation of the steam, whatever the exhaust product or the products, byproducts of the combustion, those are called as, generally called as the flue gases. Now, generally what we do, we directly release those flue gases into the atmosphere. But that flue gases is also considered some pollutants, which are going to contribute into the air pollution of that particular into the air pollution. So these those flue gases will contain different types of the air pollutants that we saw in the previous lectures. That is a sulfur dioxide is there, carbon monoxide is there, carbon dioxide is there, unburned hydrocarbons are there, then the oxides of the nitrogens are there. Also, it will contain the fly ash. So that flue gases, we have to treat that particular flue gases before we releasing into it the atmosphere. Because as we know, the sulfur oxides will going to going to create, or it will uh, uh, because of the sulfur dioxide, the acid rains will causes, it causes also, because of the nitrogen oxide, it will causes, or it will dangerous to the human being. It will also going to affect the other factors, uh, uh, other factor inside the environment. Also, the release of the carbon dioxide, it will this carbon dioxide will having very high potential, greenhouse potential. Okay, so because of that, we have to treat that particular flue gases before we releasing into the atmosphere. So before treating that particular flue gases, we have to measure how much amount of pollutants are present inside that particular flue gases. Also, we can find out by measuring those gases of the or the constituents of that flue gases, we can also predict the efficiency of combustion. Okay, take an example. By measuring the value of O2 or the oxygen present inside the flue gases, we can find out the efficiency of the combustion. If there is an incomplete combustion, if we are providing less oxygen to the combustion, in that case, there will be a very less extent or the very less amount of oxygen will present inside the flue gases. Okay. Similarly, if that particular flue gases will contain the more amount of carbon dioxide or the more amount of carbon monoxide or the free oxygen, means that we are providing the extra air or the extra oxygen to the combustion process. So by measuring the content of the flue gases, we can also predict the efficiency of the combustion and how efficiently the combustion has been taken. So by using the measurement gas analysis also, we can control the combustion process, which will and try to uh, increase or to provide any efficient combustion process. Okay, so these gas analysis, for that we have to measure first of all how much amount of CO2 is present, oxygen is present inside the flue gases. Okay, and for that we can use the different methods. The first method that we are going to saw here to measurement of carbon dioxide by thermal conductivity. Okay, so we can measure the carbon dioxide by using the thermal conductivity property of the flue gases. Okay, so how to measure that one, or how to measure the CO2? So measurement of carbon dioxide by thermal conductivity measurement. Okay, this is one of the methods to which we can calculate the CO2. The proportion of various constituents of the flue gases, which can be determined by measuring the thermal conductivity of the gases, because each gas is having different properties, having different characteristics. So each gas will contain the different thermal conductivity. If we consider, or if we saw the thermal conductivity of the air, which is at 0 degree centigrade, we are considering that is the 1. Okay. If we consider that air having thermal conductivity as 1, one of the scale we are considering, we are taking air as a reference. So the air is having thermal conductivity 1 at 0 degree centigrade. Then the thermal conductivity of CO2 with respect to air, thermal conductivity of hydrogen, nitrogen, and oxygen with respect to air, it will be 0.585 in the case of CO2, 7.35 in the case of hydrogen, 1.015 in the case of nitrogen, and 1.007 in the case of oxygen. Okay, so if that flue gases will it's having very high thermal conductivity, in that case, what we are going to conclude that is this flue gases will contain more amount of hydrogen. More amount of hydrogen is present inside the flue gases. Similar to that, if the thermal conductivity of that flue gas is very less, it will less than 1 if we, with respect to air, then in that case we are considering it will contain maximum amount of carbon dioxide. Okay, so if the maximum amount of carbon dioxide is present, then we can consider there is a efficient combustion has been taken place. Okay, because carbon dioxide is a byproduct of any combustion process. If you in the cases of the coal and petrochemical products. So carbon dioxide means if more amount of carbon dioxide is present, then we can consider more efficient is combustion process. And in that case, to reduce the level of carbon dioxide, we have to carry out or treat that particular flue gases. For that, we can use the different methods like the EGR method is there. Then we can use the catalytic converter to reduce the level of CO2, etc. Okay, so how to measure that thermal conductivity of that particular flue gases. For that also you can see there is one electric circuit or this particular method we can use. Now what we do here, we are going to compare the thermal conductivity of that sample with respect to one reference fluid. Generally, this reference chamber or the reference fluid, we are using air as a reference one. Okay, so with reference to the air, we are going to find out the thermal conductivity of that particular sample or the other particular or the flue gases. Okay, so what will happen here? You can see there are two chambers are there. This is a chamber number one, and this is a reference chamber. Okay, this one is called as a reference chamber. This one is called as a measurement chamber. And inside the chamber, you will see this particular one wire is there. Okay, and this element you can see here. This is the tungsten filament. Okay, this is the tungsten filament. Similarly, here also this you can see there is this tungsten filament, and this has been joined inside the Western bridge circuit. Okay, so this one is known as a Western bridge circuit, which will contain the different resistance R1, R2, R3. This is the R4, and this one is the R5. Okay, so this is the Western bridge circuit, electric circuit you can see, and the output of this particular one, it has been given to this amplifier to amplify the output, and it will going to directly connect it to the pointer or the scale. Okay, so on this particular scale you will see how much difference between the reference or between the thermal conductivity of reference air and the sample air or the sample gas. Okay, so what we do, we just introduce the sample inside this measuring chamber. Okay, on the other side in the reference chamber there is air is present inside the reference chamber or the reference in this reference particular chamber, which is filled with the air. Okay, now what will happen, we connect this particular one in the Western bridge circuit. When current starts flowing, it will flow through this filament. Okay, and because of the resistance of the filament, what will happen, heat will be generated at that particular filament. The same principle we are using in any particular electric bulb. Okay, old electric bulbs, if you saw, there is one filament, and when we passing the current, because of the resistance, it will illuminate. Okay, and that is the property of that tungsten filament, and it will create the heat, and that heat will be some energy will be converted into the heat, and some energy converted into the radiation. Same principle is used here. When electricity passing through that particular filament, it will illuminate, or the electrical energy will convert it into the heat energy. Okay, so now what will happen if this gas which is flowing inside this particular measurement element or the chamber, If this gas is having more thermal conductivity, in that case, it will absorb more and more heat from this particular filament. Okay, the air is having constant properties. It will absorb these some amount of heat. Similarly, here also this gas will absorb or it will take away the more and more heat if the thermal conductivity of gas is more. Okay, so in that case, what will happen? The temperature of this filament will be decreases, right? Temperature of this filament will decrease. Consider this gas, flue gas having more conductivity than the air. So when it passing through that particular filament or the chamber, it will absorb more and more heat from this particular filament, and because of that, temperature of this filament will decrease. Similarly, air is having constant characteristics. We are taking this one as a reference. So in that case, it will also absorb some heat. Okay, and because of that also the respective temperature you can see here. But the thermal conductivity of this gas is more than the thermal conductivity of air. Because of that, what will happen? The temperature of this filament it will be less than the temperature of this reference filament. Okay, so temperature of this measuring filament is less than the temperature of the reference filament, and because of that, what will happen? The resistance which is offered by this filament will be decreases. Okay, because resistance is depends upon temperature. Okay, when we vary the temperature, resistance will be vary, or is going to be vary. And because of the variation in temperature, resistance will vary. And because here resistance is different, here resistance is different. Because of that, imbalance of this particular piston bridge taken place. Okay, now to balance that piston bridge circuit, slider has been provided. By using this slider, we can balance this particular resistance inside the piston bridge. Now, the output given by this particular slider, which is included or which is amplified, and it will shown on the scale, and that's how we can find out the CO2 content inside the gas. As we know, if we saw the thermal conductivity of CO2 with respect to air, which is very less, right? So, if consider here the temperature will increases because as we increases the thermal conductivity, temperature will decreases, right? So as thermal conductivity, if we take a reverse of that, if thermal conductivity is decreasing, temperature of this filament will increasing, that will increases the resistance, and that will shows the amount of CO2 present inside the flue gas. Now, this is the if we consider the ideal case, that will going to show you the exact amount of CO2. But in actual practice, what will happen? There are some drawbacks also. Okay, there is some drawbacks of the particular method. Okay, what are the drawbacks? Sometimes these if appreciable hydrogen gas is present inside the flue gases, it will going to also showing the same reading as per the CO2. Okay, CO2 content. So because of that, what will happen if even CO2 is not present, only hydrogen is present inside the gas? In that case also, that particular meter is showing the wrong reading. Okay. Similarly, if the water vapor is present inside the flue gases, okay, that is also going to cause the variation inside the in the reading of that particular instrument. Okay, so that's how it. There are some drawbacks also, but by using this simple method, you can measure the amount of CO2 inside this particular flue gases. Okay, so in the case of CO2, what is happening? The conductivity of conductivity of CO2 is very less, so because of that, it will absorb less amount of heat. So here the temperature will be greater. Here temperature will be less whenever we compare it, comparing these two temperatures. And because of that, what will happen? Respective resistance will be there from this particular element. Okay, and here also the respected resistance will be there. And because of that, unbalancing will happen, and that unbalancing is directly proportional to the amount of CO2 present inside the flue gases. Okay, but there are some drawbacks as we already discussed. Because of the availability of hydrogen gas or the water vapor inside the two gases, it will going to show the variation inside the variation in reading. Okay, that will cause the error in reading, and that will going to affect the correctness or the accuracy of this particular reading. Okay, so this is how you can measure the CO2 content inside the flue gases. Okay, so that's it. We will stop here for today's lecture. The remaining measurement of the oxygen inside the flue gases, and also the measurement of VO, etc., that we are going to see in the coming lecture. Okay.